Hey everybody, this is Larry. I don't even know if I know how to set this up anymore, but it is the last day, I think, of the June Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. We'll be doing this, or I don't know, right? I mean, I did a 2-month trip and we're still here, so we'll be doing it all July, so hit the like button, hit the subscribe button, and all those other buttons. Today's problem is, and you can see, I'm back in New York. I probably will post up some belated drone videos just because, man, I have a lot of good ones, I think. So we'll see. Anyway, today's problem is 1970, last day where you can still cross. So guys, there's one base binary matrix with 0 represents land and 1 represents water. Each cell begins, okay, so we're going to choose the last day. Okay, and these are the day effects. Okay. Let's see, right? Rows times column is so that's the number of total cells, and it has 2 by 2 at least. Okay. Let's see. Okay, so then now we could cross. So I think from top to bottom by only walking, you can up, down, left, right. Okay, I feel like I missed this in some problems recently where I confused the traveling directions. I just want to make sure. I think this is basically and diagonal, up, down, left, right. I think this is basically this is one of those problems where you're trying to ask almost the opposite, where you're trying to figure out how to, from top to bottom, but maybe the way that you cannot go from top to bottom is if there's a river, or whatever you want to call it, a body of water that connects from left to the right, then that means that you're blocked off and you cannot go, right? And with that, I think you can do union find a disjoint set union, or this, data structure to kind of calculate that. Am I right? And then with that, you can simulate one cell at a time. I think that should be okay. Let me give that a try then, right? So first we have to do the union find stuff. So I'm just going to put it in a set, or maybe a defined set of. No, let's just put it as a set. And then the find operation for a cell. Maybe I should, so I'm still just setting this up. Hopefully this should be good. Is equal to you find parents of key, right? Something like this, right? And then definitely union is x, a, y, bx, by, right? Something like that. Is equal to find of ax, ay, ub is equal to xby, and then parent sub UA is equal to B. Something like that should be good enough. And then, yeah, and then we just kind of, so basically, and we want to add maybe like a left one, right? So left is equal to 0, right is equal to 1. This is just enum, lazy enum, right? So we set this parents. Maybe you should do parents. I don't know. Right, or you know. So then now we can do something like for I xy and enumerate cells. Yeah. Now if x is equal to if y is equal to 0, then we do a thing to the left, right? So we union. Oh, this union is kind of bad, I guess. And maybe we have to do another union. Because we want to write something like left and xy, right? Something like that. Maybe I'll just write it here. Right? This is actually annoying. Maybe I'll write this a little differently then. Maybe I'll do right as in. This is so hacky. But this is why we have enums. Jeez. Does that work? Maybe it does. I don't know if this actually does. It should, but maybe not. If y is equal to the last one, which is called -1, we union the right. That's definitely not right. What is this left even? And also this should be 1 and cause apparently that's why it didn't for an hour. I think it should for an hour, but maybe I'm wrong. Oh, Okay. Yeah. And then otherwise, we want to connect it to one of the 8 adjacent cells that are water. So actually, we also want to do maybe a scene type thing, right? Otherwise, scene.add cells. Oops. XY. And then we do something like let's keep consistent. Something like that, right? Basically, we're just looking at the 8 directional adjacent things, and then we check to see if they're in it. If x and y is in scene, then we union xy with the nx and y, right? Okay. And then now, if you find of left is equal to you find of right, then we return I. Yeah, maybe off by 1, but that should be okay. Otherwise, we return just the last number, right? So, yeah, we still return I think. Oh, I don't know if it's I or I plus 1. Yeah, let's do length of cells. Right. Is that not? Oh, huh. Man, I'm a little bit rusty for some reason. So that looks okay. I'm to be honest, am I confident? Not really. So let's give it a submit and see if I missed an edge case. It looks okay. So maybe I was right on this one. Yeah. For the sake, I mean, I know that I didn't necessarily implement it that way, but for the sake of argument, let's just say, you know, these are all of one operations. In that case, then you can see that this is all of one, this is all of one. We do at most 8 operations that are all of one, and the more all of one operation. So we're basically doing, for every query, we're doing all of one operation. So it's all of Q, all of Q time and space, because we have to do the union is depending on the number of cells that we've seen so far, and so I've seen. So yeah, that's all I have for this one. Union fine, and yeah, all of Q time, all of Q space, and that's all I have. Let me know what you think. Stay good, stay healthy, do good mental health. I'll see y'all later and take care. Bye bye.